Okay, in this video, I'm going to try to help you step through the Module 7 lab activity about extrasolar planets. This first video, actually, I'm going to make a series of videos that's going to step you through the student guide, and then I'm going to make a separate video that will deal mainly just with the lab quiz. But as with always, I always encourage you, go through the student guide, friends and neighbors. It's going to make the quiz so much easier, trust me. So, of course, you've printed off your extrasolar planets student guide. Go through the introductory material, go through this main content, make sure you understand it. So again, I'm not going to go through too much about this, but this is mostly about the solar nebula hypothesis. You're familiar with that. The second one is about center of mass. Now, center of mass is very important to understand. It's very much like when you're sitting on a seesaw, where you're essentially rotating around the pivot point, and you've got one friend on one side and the other friend on the other side, and depending on their masses will determine how close they should sit to the center in order to be balanced. And that's essentially what's going on when you've got a star and a planet. And in this lab activity, we're only going to be dealing with a planet that has a star that has a single planet around it. We're not going to deal with multi-planet systems, so that'll keep things a little more simple. But in the case of a planet going around a star, they actually orbit around a mutual center of mass. That's what CM stands for here. So make sure you understand what a center of mass is. Doppler shifting. Of course, you notice that the star was shifting, right? The star was moving around a center of mass. It wasn't just that the planet was going around the star was moving as well around a center of mass. And when you're viewing the star, then you can start to notice those wobbles, and those wobbles will show up as Doppler shifts. And so there's a little activity here, a little simulation, which allows you to play around with shifts. So notice right now, we've got this, what's called a laboratory wavelength, this lambda with a little zero beside it. That's the wavelength or an absorption line that you would expect from this star, a characteristic absorption line of, say, hydrogen, that you would expect if this star was not moving, or if it had no radial velocity. Notice that this star is moving, but it's moving kind of perpendicular to the Earth, so it's not moving toward or away, and therefore it has no radial velocity. Now you can change the angle. You can make it move away. You can make it move toward. You can change the speed at which it's moving, and that will change the amount of shift. So I encourage you to play around with that to understand fully what a Doppler shift is, because without the Doppler shift, without understanding a Doppler shift, we wouldn't be able to use one of the fundamental techniques, which is the radial velocity method. Now, there are several ways of detecting exoplanets or extrasolar planets, including direct detection, which they describe here, which is, could you actually see the planet? Well, I suppose so, but they're planets are really small. They don't produce their own light, and stars produce a lot of light, so it's really tough to directly detect a planet. You're much better off using indirect detection techniques, astrometric, meaning just observing wobbles, which is also relatively tough. The much more common method is the radial velocity method, which is described in here. One thing I will warn you, and when you're reading through this, make sure there is a typo in here. It says a redshift yielding positive radial velocities when the star is moving toward the Earth. That's not correct. That should be when the star is moving away from the Earth. So make sure that you understand that when you've got these positive values for radial velocity, that means that the star is moving away from the Earth. Okay, a blue shift, when you've got negative radial velocities, that's when the star is moving toward the Earth. But these radial velocities, this is not the velocity of the planet. This is the velocity of the star. Okay, but these are the shifts that we're actually looking at. We're seeing the shifts in the star's spectrum, and therefore we're figuring out the radial velocity of the star. And then finally, there is the transit method mentioned down here, which is another way of figuring out whether there's a planet orbiting a star. And that would be essentially by looking for drops in the star's brightness. Essentially, when the planet moves in front of the star, it essentially eclipses the star and therefore decreases the brightness of the star. Okay, so that's the background information, and I think that's probably where I'll leave this particular video, and we'll pick up with the rest of the student guide in the next video.